Friends, welcome to my YouTube channel. Dhanesh here. In this video, I am going to talk about machine learning math. See, in this video, we are discussing on partial differentiation. This video will be part of the machine learning math. We have already have a couple of videos related to math we use in machine learning. So I will be coming up with more videos. Please subscribe my channel. So this is about partial differentiation. See, when we discuss about one important example I can tell you is when we discuss about cost function. Cost function, we will be, we are using partial differentiation. Cost function or error function, it is the predicted value minus target value, that. See, when we talk about cost function, we come across partial differentiation. When we write normal differentiation, we will use dy by dx. But when we talk about partial differentiation, we will write dou y by dou x. This dou stands for dou. It's a Greek letter. Dou stands for partial derivative. So when partial differentiation comes into picture, that's what we want to discuss. For example, when in normal differentiation, you have a function y is equal to x square plus 3x. So this function y, it depends on x. X is the independent variable and y is the dependent variable. You know it. So y depends on only one variable. Here if you see, y depends on only one variable, that is x. At that time, when you differentiate, you will use the normal differentiation, that is dy by dx. You can write it as x square, it would be 2x, plus 3x, it would be 3. The formula we are using is derivative of x raised to n is nx raised to n minus 1. You know it. But consider another variable. For example, I am having an equation like this. F of x, our function, f, it depends on two variables, f of x comma y, then it is 3x square plus 5y cubed. So this function, it depends on two variables, x and y. Then the derivative, we can denote it as f dash of x of y. This we will write it as, this derivative you can differentiate with respect to, that is, you can write it as dou f by dou x. That is one derivative. That is, you can differentiate this function with respect to x. At that time, y is a constant. So at that time, you will get 3 into 2x, that is 6x. So when you differentiate with respect to x, here y is a constant. In the same way, you can differentiate the same function with respect to y as well. So you can write it as dou f of xy with respect to dou y. At that time, x is a constant and this term will disappear. The derivative of that term is 0, and you can write it as, the derivative of 5y cubed. So 5 into 3y square, that is equal to 15y square. So as we discussed, the partial differentiation comes into picture when a function depends on multiple variables. When a function depends on only one variable, the normal differentiation. I can tell you another function, f x y comma z. So it depends on three variables x comma y comma z. The function is 3x square plus 5y plus 6z. So when I can differentiate this, see this is plus, this is plus, okay. I can once again, this is plus, this is also plus. So this function you can dou f divided by dou x. At that time, y and z will be constants. So this is 6z. 6z. So y and z will be constant. So the derivative will be 3 into 2x. So 6x. You are familiar with the rule x raised to n. Derivative of x raised to n is nx raised to n minus 1. That's only we are using here. So dou f by dou x is equal to 6x. In the same way, you can get into this as well. See dou f by, I can write dou f by dou y. At that time, these two terms x and z will be constant. Then you will get 5 because derivative of y is 1. 5 into 1, 5. In the same way, you can get into dou f by dou z. At that time, you will get dou f by dou z. At that time, x and y will be constants, and you will get it as the answer as 6. Derivative of 6 that is 6. So this is the concept of partial differentiation. When a function depends on multiple variables, you will go for partial differentiation. And the same thing you might have seen in cos function when you discuss about artificial neural networks, when we discuss about convoluted neural networks or recurrent neural networks, or LSTMs. Everywhere we use weight and bias. See, this cos function again depends on two variables. One is the weight and another one is the bias. You know this, weight and bias. Again, this function depends on weight and bias. See this j cos function, if we are taking it as, if it is denoted by the letter j, it depends on two functions. So you can take the partial differentiation dou j with dou w. At that time, b will be a constant. This bias will be a constant. When you differentiate dou j with dou b, at that time again weight will be a constant. So this is the concept of partial differentiation. We use a cos function as well. So partial differentiation is an important part in calculus. So the point you need to understand is when a function depends on multiple variables. See, there are dependent variables and independent variables. When I am telling y is equal to x square, x is the independent variable and y is the dependent variable. Here j is the, when we talk about cos function is the dependent variable, and it depends on the weight and bias, and weight and bias are the independent variables. So when a function depends on multiple independent variables, we define cos function. Sorry, we define a partial differentiation. So you understood that. So that's why we are going with the partial differentiation with respect to cos function. So that's all about partial differentiation. Thanks for watching. I will be coming up with more videos on machine learning, artificial intelligence, data science, math, statistics, probability. So please subscribe my channel.